All right, let's take a look at a few examples of using the product and the quotient rule. So I've given you 4 examples, and hopefully you can kind of first just differentiate which ones are going to use the product and which ones will use the quotient rule. So this one will use the quotient rule because it's of form f of x over g of x, right? This one will use the product rule because it's of form f of x times g of x. This one will use the quotient rule, again because it's of form f of x over g of x. And finally, this one will use the product because it's of form f of x times g of x. Okay, well, let's go ahead and start with this first one first. Cut it out and add a new page here. It's weird it didn't lasso it. There it went. Let's go ahead and copy that. I don't know if that was even worth the time. Okay, so off we go to the races. So let's see. Think of f of x as being, I'm going to call it g of x over h of x here. And it's going to be the bottom, h of x times the derivative of the top, g prime of x minus the top, g of x times the derivative of the bottom, h prime of x, all over the bottom one squared. Where here we have the following. What? We have on top g of x, that's equal to 2. So g prime of x is going to be equal to 0. And on bottom we have h of x equals to x squared plus 2x, which means that h prime of x is going to be equal to 2x plus 2. So now it's just basically plugging these pieces, right, into a template for the quotient rule. So let's check it out. Sorry, I should say I have a little bit of an error here. So if f of x is that, then what I really wanted to say was that this is equal to f prime of x, right? That's the derivative of f of x. Okay, so let's go after it now. So f prime of x is going to be equal to, first I have h of x on top, so that's going to be x squared plus 2x, so it's the bottom, times the derivative of the top, which is 0, minus the top, which is our g of x, or 2, times the derivative of the bottom, 2x plus a 2, and that whole thing over the bottom expression, h of x squared, so it would be x squared plus 2x quantity squared. Let's add another page. So I can see right away that this piece goes away at 0. I can distribute the 2 across this. It's a negative 2. So on top, I guess what I get is negative 4x minus 4. And on bottom, what I get is x squared plus 2x quantity squared. There might be a little bit more that we could do here to simplify. It's a perfectly good answer, but if I took the, if I factored the top, I could take out a -4, and I'd get x plus 1. And if I factor the bottom, inside the parentheses, I could take an x out, and what I would get x plus 2 quantity squared. So I guess there isn't anything I can cancel. But this might be another form, perhaps a book form of the answer. And that's our first example problem. I wonder if we could go to Desmos and check it, see if I have an internet connection that's strong enough for us to do that. Yeah, we're good. Okay, the first thing I'm going to put in is the function. So let's see. Here I'll write f of x equal to, our function was 2 divided by x squared plus 2x. So a picture of our function, I guess. So I guess looks like we have vertical asymptotes at 0 and at -2. I guess that's because the denominator goes to 0 at those two values. Let's see what the derivative looks like. So f prime of x. Let's make that a dotted line. So the blue line then would be the derivative function for the red function, and we think we know what that function is based on the quotient rule that we just calculated. Let's call it g of x. And we think it's going to be on top a -4 times x plus 1. That whole thing divided by parentheses x times parentheses x plus 2 in parentheses, and that whole thing squared. And sure enough, it looks like when I turn that green function on and off, it perfectly matches Desmos's machine derivative in the blue. So we must have indeed found the first derivative. I'll start another video here to do the second example problem.